answer solution reactions. First of all, what does it mean, a solution reaction? In a solution reaction, one or more of the reactants is in solution. What does that mean? Well, here we can see that there are two reactants in solution. We can recognize that by the symbol AQ, aqueous. Let's look at silver nitrate. What does it mean that we have a solution of silver nitrate? AgNO3 aqueous. To get silver nitrate solution, you might start off with some solid silver nitrate and mix that with some water. Stir them up and make them dissolve in one another. Then you have a silver nitrate solution. So a solution is not a pure substance, it's a mixture. It's a mixture of something which used to be solid in maybe water, a solute in a solvent. Doesn't have to be water, but in this case it is water. So the important thing about solution reactions is to realize that the information you're given about the solution refers to an impure substance, the whole mixture, the whole solution. But it isn't the whole solution that reacts. It's only, in this case, the silver nitrate itself, the solid inside all that water. And so in a solution reaction, you first have to find out how many moles, maybe what mass in grams, but it's usually easier, how many moles of that active ingredient is inside that solution. And that's relevant to the reaction. Other things you must be careful of remembering is that 1 milliliter is the same thing as 1 centimeter cubed. And there are 1,000 centimeter cubed in 1 decimeter cubed. And decimeter cubed is what we want. We want volume of that solution in the unit decimeter cubed. And the reason for that is that the unit of concentration has decimeter cubed inside it. And so we need decimeter cubed in our volume so that we can do cancellations. The unit of concentration is the molar. Capital M is molar, and molar in full is mole per decimeter cubed. 1 molar is 1 mole per decimeter cubed, and that's because concentration is equal to the number of particles, number of moles, divided by the volume in the unit decimeter cubed. So C is equal to N over V. That's in symbols. In units, molar, capital M, is equal to mole per decimeter cubed. We can also write that as mole dot decimeter to the power minus 3. Here I've included the information about the elements relevant to this particular question from the periodic table. And we know that the smaller number is the atomic number, which is not relevant here. The bigger number is what we're interested in. That's the atomic mass and also the molar mass. And that is important here. So now it's time to look at our question. Before we do so, let's just look at this equation here and make sure we understand what's happening. So we have two reactants, both of them in solution, silver nitrate and potassium chromate. They react together to form two products, silver chromate and potassium nitrate. Now, potassium nitrate is also in solution, just like the other chemicals, but silver chromate is the odd one out. It is not in solution because it cannot dissolve in water. It is insoluble. So it precipitates out. We could have drawn a downward arrow instead of writing the S. The S stands for solid, and the downward arrow also stands for solid, but it just emphasizes that it's the odd one out. It's precipitating out of solution. So let's read our question. What mass of silver chromate will precipitate? So we want to know how many grams of this precipitate will form when 150 milliliters of 0.5 molar silver nitrate is reacted fully. So here we have the silver nitrate, and we have two pieces of information about the silver nitrate. We have 150 milliliters, that's the volume of the silver nitrate. We immediately change that into centimeters cubed. Milliliter is the same as centimeter cubed. And then also into decimeter cubed, because when we work with concentration, we need the volume in decimeter cubed. And we know we must just simply divide by 1,000. So that's 150 divided by 1,000, which is equal to 0,15 decimeter cubed. So that's the first piece of information about the silver nitrate. But it's not all we have. We also have the concentration. So this is the volume of the silver nitrate that we have. But we also have the concentration of the silver nitrate, which is 0,5 molar. In other words, 0,5 moles in every decimeter cubed of solution. 0,5 moles of the solid, of the active ingredient in every decimeter cubed of solution. So we have two pieces of information about our silver nitrate. Why do we have two pieces of information about the silver nitrate? Because the silver nitrate is in solution. Remember, we have some active ingredient mixed with water all together making this solution. But only the active ingredient, not the water, reacts in this equation. And so we need to sort of separate the information about the active ingredient from that of the whole solution. And that's why we need these two pieces of information to do that. But how do we do that? We need to know how many moles of silver nitrate solid, the active ingredient, is inside this particular solution, which has these characteristics. So we can write a sub-question for ourselves. How many moles of silver nitrate are inside 150 milliliters, which we've already calculated is 0,15 decimeter cubed of 0,5 molar silver nitrate? Remember that concentration is equal to number of moles divided by volume. So therefore, number of moles is equal to concentration multiplied by volume. We want to know the number of moles. We are given the concentration 0,5 molar, which is moles per decimeter cubed. And we are given the volume. Now remember, this one we've already converted into 0,15 decimeter cubed. 0.5 times 0.15 is equal to 0,075 moles of silver nitrate. This is now not silver nitrate solution. This is silver nitrate solid inside the solution. So now we know how much active ingredient, how much silver nitrate active ingredient there is. We can change these two pieces of information we were given by this one single piece of information, 0,075 mole of silver nitrate. And now our question becomes very easy, because now our question is, what mass of silver chromate forms when 0,075 moles of silver nitrate reacts completely? So our question is about silver chromate. We want to know what mass, how many grams of silver chromate forms. And our given information is about silver nitrate. We know how many moles of silver nitrate are present. 0,075 moles. We've just calculated that. So then how do we find out the answer to our question? The first step is to give reacting ratios. So we use the balanced equation, and the balanced equation gives us the mole reacting ratio. We know that 2 moles of silver nitrate react with every 1 mole of potassium chromate to produce 1 mole of silver chromate and 2 moles of potassium nitrate. Now this table is asking for the mass ratio of all of these elements, but in fact we can save ourselves some time because we know that the question only has 2 relevant things: the mass of silver chromate which is produced and the number of moles of silver nitrate which are needed. And so we only actually need a mole mass ratio for these 2 chemicals, silver nitrate and silver chromate. And we know that 2 moles is obviously 2 moles. I don't actually need to rewrite that, but in any case, the more difficult question is how many grams of silver chromate is the same thing as 1 mole of silver chromate. So we go to the periodic table and we look at the molar masses. So we're trying to find the molar mass of Ag2CrO4. So the molar mass of this is going to be 2 times 108 for the silver plus 52 for the chromium plus 4 times 16 for the oxygen, which gives us 332. That's the mass of 1 mole of silver chromate. So now we know the reacting ratio, the ratio in which these two chemicals always react in this particular reaction. 2 moles silver nitrate produces 332 grams of silver chromate, but we don't have 2 moles of silver nitrate. That's why 332 grams is not the answer yet. We only have 0,075 moles of silver nitrate. So we need to apply this ratio to this particular situation to answer the question, what mass, how many grams of silver chromate forms when 0,075 moles of silver nitrate reacts completely. To answer this, we need a reaction ratio, which we get from this table at the top, how they always react, in what proportion they always react, making sure that we have moles of silver nitrate at the bottom and grams of silver chromate at the top, so that the given unit cancels out and the required unit is introduced. For this particular reaction, 2 moles of silver nitrate always produces 332 grams of silver chromate. Therefore, how many grams of silver chromate will 0,075 moles silver nitrate produce? 0.075 multiplied by 332 divided by 2 is equal to 12,45 grams of silver chromate. So let's just recap what we've done in this question. The first step was that we converted 150 milliliters into decimeter cubed, remembering that milliliters is the same as centimeter cubed, and to convert from centimeter cubed to decimeter cubed, you must divide by 1,000. After that, we made our own little question. From the information, we made our own question, finding out how many moles of the active ingredient is inside the solution. And we used this triangle to help us. So we multiplied the concentration by the volume to find the number of moles of silver nitrate active ingredient are inside the silver nitrate solution, so that we could replace the 2 pieces of information, volume and concentration given in the question, with just one useful piece of information, the number of moles silver nitrate in there. And after that, it becomes just a normal reaction kind of question, where the first step is to get the reaction ratio. And you can do the whole long process, if you like, of working out all the mole ratios and all the mass ratios, but you don't need to. You can realize this question is about a mole-mass ratio, because mass is asked, mole is given. Well, we gave ourselves mole. So we just need the mole-mass ratio for this particular reaction, for silver nitrate in moles and silver chromate in grams. So we did that using the equation and the periodic table. So we had the reacting ratio, 2 moles of silver nitrate always produces 332 grams of silver chromate. And after we had that, we simply applied that reaction ratio as a unit factor to this particular situation of how many moles of silver nitrate react to find out the amount of precipitate that was formed.